My dear friends, welcome back. In this video we are going to complete what we have left in this chapter. So let's begin with the second part of the chapter, in which we will begin with the weather and climate. We will look into the differences that we have in the weather and climate. Then we will look into the air pressure, and then we will look into low pressure area, then high pressure area, then what is the type of rainfall we have, the type of winds we have. Okay, so let's start with the phenomena of weather and climate. Okay, so let's begin with this concept of weather and climate. We will try to understand both of these concepts, and then we will also try to understand what are the differences when we say weather and climate. But before we begin, let me look into behind the camera if everything is going right. Okay, because in the previous video we had some technical issues with regard to the video. So yes, everything is going fine. So let me continue with this topic. So okay, so when we say weather and climate, what actually is the weather? Okay, so let's try and understand what actually is the weather. So when we say weather, if you ever have watched the weather forecastings on television, or if you have heard it in radio, or if you have even see it in your mobile smartphone, whatever you have, or even in newspaper also we have weather forecasting, you will see that some of the elements that are considered while forecasting weather is the temperature that will be tomorrow or after 10 days. So what will be the maximum temperature that we may encounter, and what will be the minimum temperature? Okay, what will be the wind conditions, what will be the speed of wind? Okay, and then you will also be coming across the rainfall that is expected or not. Okay, so when we say weather, it is the it is the atmospheric condition prevailing over a small area during a short period of time, right? During a short period of time. Okay, now let's understand what are the technical terms that we have. So this is the atmospheric condition. Okay, then prevailing over a small area, and then a short period of time. These three are very key concepts to understand here. Not concepts as per, but these are the three important words or the area that you have to concentrate upon. My dear friends, if you are watching this video, have a pen and a notebook in front of you and make note of all these terms. And the most important thing in geography is the diagram. If you do not understand the geography through diagram, you would not be able to comprehend it better. You will not be able to keep these concepts in your mind for a longer time. Just do not watch this video. Watch this video 2 times, 3 times, and as much time until you do not get clarity. And you will get clarity only when you write and you try to understand through diagram. That is very important. Okay, so it is the atmospheric condition. Now when I am saying atmospheric condition, what all consists in this atmospheric condition are basically temperature, wind speed, or rainfall. Okay, that we will see in the components. Then it is in a smaller area and over a shorter period of time. When I say short period of time, it may be hourly. You may have hourly weather forecasting, it may be daily weather forecasting, or it may be weekly or monthly. You can have monthly weather forecast. Okay, so I am basically referring to this short period of time. When I say short period of time, it means it can be hourly, daily, or weekly, or it may be monthly. And when I say small area, it means the area may be town, it may be a city like Delhi, it may be like Patna, it may be like Allahabad, or it may be like Chennai. Okay, but you cannot have a weather of entire India. Okay, that's a big place. Now let's understand climate. What is this climate? So when we say climate, this is the average of weather conditions, the average of weather conditions over a large area, right, over a large area for an extended period of time, over an extended period of time. Now again, we have some key terms here. Average, first thing is that it is the average. Average of what? Average of weather conditions. Here is weather, and when we calculate climate, when we talk about climate, it is basically the average of weather conditions over a large area and over an extended period of time. And when I say extended period of time, basically I am trying to tell you that it is from 30 to 35 years average we calculate when we try to find out the climate of a place. And when we say climate, you see, climate is of a large area. It's for an extended period of time we take the average of weather conditions. Let's try to understand here. Suppose on 1st January 2023, 2022, the upcoming year, you have temperature, maximum temperature, suppose 30 degrees Celsius. Temperature minimum, the minimum temperature is suppose 20 degrees Celsius. The wind speed, let's say, is something like 5 kilometer per hour, or suppose 2 kilometer per hour, or meter per second, whatever you want to. It's just an arbitrary number. Okay, then you have rainfall of suppose 200 centimeter or 200 millimeter, whatever you want to take. Now similarly, we have the weather conditions of 2nd January, then 3rd, 4th, and the entire month of January. Then we will have February. We will calculate the average of this month. Then we will calculate the average of entire year, and then we will calculate this average for 30 years, and then we will find a type of pattern that is prevailing. That is, over a period of 30 years, if you will find the average of weather conditions over a period of time, over a place, you will find that there are certain type of, there are certain type of trends that you will find. That is, the maximum temperature maybe goes to like 40 degrees Celsius at max, and the minimum temperature may goes to 15 degree at max. And if you will find the average of 30 years, you will find that somehow the temperature differences we have, the rainfall that we have, or the wind speed that we have, that has certain amount of variations between 2 points. And when we come to a conclusion that okay, this area receives this how of temperature, this much of temperature, we will say that this area is basically a hot area, or we say it's a cold area. Okay, so this way we try to find out the climate of a place. So if someone asks you what will be the difference between the weather and the climate, so just three things you need to remember. First, it is the atmospheric condition for a small area, but climate, when we talk about, it's of a large area. Second, it's for a shorter period of time, means hourly, daily, weekly, monthly. But when we talk about climate, it's for 30 to 35 years. Okay, when we say climate, we say the average of weather conditions over 30 to 35 years. And the most important difference is that the weather is subject to frequent change. Weather of a place can change frequently. And when I say frequently, it means that suppose it is 10 a.m. in the morning, and if you will see the weather conditions in 11 a.m. in the same day, you will find that there is some amount of change that has taken place. There may be change in wind speed, there may be change in the temperature, okay. And similarly, when you will compare the 10 a.m. and 10 p.m. temperature, you will find that there is a difference, because during day temperature is high and during night temperature will be low. So the basic the main point I want to make here is that the weather is subject to frequent change. But when we say climate is more or less stable, right? So when we say climate is more or less stable, it does not change, okay, because we have found the trend for 30 to 35 years. So what is the benefit if it goes on changing every year? Now this word climate change, you will come across very frequently in news or magazines, etc. And climate change and global warming, which we have discussed yesterday, you will find these two terms are very frequently used, and especially climate change, because we have conferences taking place at the international level for how to deal with climate change. So what is this climate change? Usually this doesn't change. These are some form of stability. There is some form of stability in the climate over a place. So how is it changing? This is changing because humans have caused a lot of destruction on the earth. And when I say destruction, what does it mean? It means that humans have caused a lot of loss to the natural elements that we have on the earth. For example, we have cut a large number of trees. We have polluted our rivers, we have polluted our air, and that is all causing climate change at a very abrupt rate. That is why you come across this word climate change, and there are lots of environmental movements taking place all around the world just to reverse this rapid speed of climate change that the world is witnessing, okay. So just remember this 2-3 points: the small area, short period of time, and high frequency of change. Here you have more or less a stable climate of a place, and this is for a large area and for 30 to 35 years average, okay. So this was the basic idea behind weather and climate. Hope you have understood it very well. This is the most basic thing you must understand, okay. This is because in the upper higher standards you will come across chapter called climatology, okay. And in that climatology you have to study these things in a very great detail. So if you do not have a basic understanding or the fundamental clarity on these two fundamental ideas, how will you deal with those type of heavy terms that will you face in higher standards? So it's very important that you understand these terms thoroughly. If you have not understood it, just go pause the video, let your mind penetrate this thought, and again watch this video if you have not understood. And I don't think you would not have understood this. It's a very not so much difficult to understand. Just remember 3 differences and you will never have a trouble, okay. So let's start with the elements of weather. What are the elements of weather we have? So let's understand, okay, only elements of weather we have to study. So what are the elements of weather? Basically what I want to say here is what you see when you when you observe the weather forecasts on television or on radio or on on your mobile itself, a smartphone itself. So 3 basic things: temperature, okay, maximum and minimum, the maximum temperature and the minimum temperature. Then you will come across this word wind. When I say wind, the amount of moisture it has, the speed that it will have, and then the rainfall. Of course there are many other elements as well, but these are three basic elements. Okay, these are three basic elements that you will find that in most of the weather forecasts these three things or these three elements are often highlighted. Okay, let's understand what is temperature. I don't think that I need to elaborate much on temperature, because you know temperature is the degree of hotness and coolness of any object. So similarly, when we talk about wind, we will deal with this wind in subsequent time, in subsequent topics, and rainfall we also deal with. So what we have to deal next with is, okay, so let's understand this temperature concept in some detail. You know that what actually is the temperature, the degree of hotness and coolness, the basic definition that you have, the degree of hotness and coolness of any place, object is called the temperature. Now when we call the temperature of a place, when we talk about the temperature of the earth or the surface, what you have to consider, the most important term that you have to consider is the insolation, because insolation is something which is the most determinant factor of temperature of a place. So let's try to understand what this actually insolation is. So when we talk about insolation, it is the degree, or it is the amount of solar radiation reaching a place. Okay, it is the amount of solar radiation. It is the amount of what? Solar radiation. You know what actually is solar radiation? The amount of heat that is coming from sun, that is called solar radiation. So actually insolation is the amount of heat that a place gets. Okay, so the temperature of a place although depends on many other factors, but this insolation is the most important factor. So I would say rather that insolation is the most determining factor of temperature of a place. It is the most determining factor, and you will understand why I am saying this. Let's try to understand with this point. At the equator, insolation is maximum. So what happens when you have maximum insolation? Temperature would be maximum. Right? Similarly, I don't know if I write below here, I think you will be able to look. Let's look at the board. If you will look into, yes you will probably look into. So at the equator you have maximum amount of insolation taking place. So that is why at equator you will find that the temperature is maximum in comparison to every other place on the earth. But at the poles, so this is a stark difference. At the pole, insolation is minimum, so temperature would be minimum. So at poles, you know that we have everything frozen. Arctic Sea, what we call sea, that is actually a frozen sea. What we call Antarctica is basically frozen continent, and both Arctic and Antarctic are at the poles. One is at the North Pole and the other is the South Pole. Because these are the polar areas, you see the sun's rays are not, the insolation of or the sun's rays are not hitting the surface directly. You will never ever find sun's rays coming directly overhead. If you are standing in Arctic, in whole 365 days you will never come across that the sun is overhead. Okay, and at the equator in 365 days you will find every day at some, if this is the earth, this is the equator, and I'm talking about at poles, and I'm comparing between poles and the equator, the insolation, the rate of insolation or the amount of insolation that is received. So when you are standing at the equator in 365 days, every day, either here or here or here or here, every day you will find at some place in equator you will find the sun is directly overhead. That is why this equator receives maximum amount of insolation. That is why this area gets maximum temperature. And at poles you will never ever have sun directly overhead. That is why here I will say T minimum, that is minimum temperature you will receive at the poles. So I hope this is very clear. Insolation is something that directly impacts the temperature that a place will have. Okay, so this was all about the insolation and the temperature. Next we have about air pressure. So okay, let's understand a very critical point. So this diagram you must draw. Okay, this diagram you must draw. Write T max at the equator and write T minimum at the both poles. Okay, this will, when you will revise these points, you will have great clarity in your mind. Okay, so just write whatever I write, draw whatever I draw. That will have immense help when you will revise all these stuffs. Okay, so if you only listen to me, if you only watch this video, it will not going to help you, because human has a tendency to forget after some period of time. So just write it down, and whenever you get free, watch this video again, watch this lecture again, and then again go through your notes that you have made. And if you will do it 2 or 3 times, I just bet you will never forget it, because the clarity with which I am taking this lecture, you will never find any problem. Okay, so let's try to understand air pressure. The next topic we have air pressure. Let's first define it. What is actually the air pressure? So when we say air pressure, it is basically the weight of, so underline this, it is the weight of a column of air, okay, contained in a unit area from sea level to the top of the atmosphere, right? Let me clarify it, what I mean when I write this. So it is the weight, you have weight. So similarly air has also some amount of weight, so it is the weight of what? Column of air. Okay, so let's suppose this is column and this is air contained in it. We have air in this column, and the area over which I will take this column will be 1 unit area. So this area is one unit area, maybe 1 meter square. Okay, column of air contained in unit area from sea level to the top of atmosphere. Now why sea level, why not land level? Why sea level? Because if you will see, land is something like this. Land you will find this something like this. you have very uneven type of surface on land. You will have somewhere mountains, you will somewhere plateaus, you will have somewhere hills, then you will also have somewhere depressions, valleys. So a very uneven type of topography we have when we talk about land. When you will go to the sea, you come across any sea, either Indian Ocean, Pacific Ocean, Atlantic Ocean, you will find that the water level is more or less same. Okay, so that is why we take sea level, because there is uniformity in the level, not unlike this land. Okay, so that is why sea level. So we take the weight of column of air in from sea level up to the top of the atmosphere. Okay, and this weight is called the air pressure. This weight is called air pressure. So when I am measuring something, we will have unit. So this air pressure is measured in millibar. Okay, this air pressure is measured in millibar, right? And also one more important point, the air pressure, when we talk about, is maximum at sea level. Okay, and it will vary on the land, and it decreases with altitude. And this is very obvious. If you are standing here, suppose, you will feel maximum amount of air pressure, but you will go, if suppose here, if you go here, the amount of air particles that this column of air has will be somehow less than what we have in this entire column. So that is why when you will go up, when your height from the surface will increase, you will find that air pressure tends to decrease. So if you stand on the land, you will have some amount of air pressure which will be higher than if you go to the Mount Everest. As simple as that. Okay, so this was about air pressure. Now two terms in air pressure you have to understand: high pressure area and low pressure area. So we know that air pressure is not uniform everywhere. Let me have some water. So air pressure is not uniform everywhere. There is difference in air pressure when you will go from one place to another. So this difference in air pressure creates pressure difference. Okay, suppose you are standing at a place called, if you are standing here on land, and if you are a mountaineer, if you become a mountaineer, suppose, and you are standing here at Mount Everest, and then you also stand at Equate Plateau at some point of time, then you will find that the air pressure that you will observe here will be maximum, and here you will have minimum air pressure. And of course, if you will go to the sea, you will find that you will have further more air pressure. Okay, so I was talking about high pressure area and low pressure area. So what is this high pressure area and low pressure area? High pressure area is basically where the winds are much closer to the ground. Whereas there is a high concentration of wind on the ground, there will be high pressure area. And when there will be lower concentration of wind, there will be low pressure area. For example, if suppose we have two places, right? Here we have larger concentration of air. Okay, we have larger concentration of air because this is cool air, this is colder air. So we have larger concentration of air here. But at this place we have warm surface, so we have less concentration of air. So this is low pressure area, and this will be high pressure area, as simple as that. And when we will see wind, we will see that wind flows always, or the air will flow always from high pressure area to the low pressure area. So if I remove this barrier, from here, you will find that this area, this air that is contained here, it will rush to this area, okay, with a great speed. So that will be called wind. So that is the concept which we will deal with now. Of course, high pressure area is some area where you have larger concentration of air, and then we have low pressure area which have lower concentration of air. And then, so let's also understand what is wind, so that we have concepts interconnected, so we should understand it in continuity, right? So of course I am facing some trouble in erasing it, okay, but I will try my best to erase everything that we have, so that you can have a clarity while I am writing, okay. So when I say wind, I have already told you that when I say wind, what is this? So this is movement of air, from high pressure area. Just write it down, high pressure area, immediately, high pressure area to low pressure area. And along with this definition you are writing, draw this diagram, and you will never forget this. Draw some dots here which are low pressure area, because this air is very low in concentration here, and here we have large concentration of air. So this wind will rush toward this area, okay. This wind will rush towards this area, that is flow of air will take place, and that movement of air will take place, of course, movement of air. And this movement of air from high pressure area to low pressure area is something that we call wind. Now when we talk about wind, we have three types of wind on the earth, okay. So let's understand about wind. So we have three types of wind actually. The one is the permanent wind, okay. And when I say permanent wind, what does it mean? It means that this is a type of wind that will continue to flow throughout the year, irrespective of what the season is, irrespective of what the weather is, irrespective of anything. Of course, there will be change in the intensity of flow, the speed of flow, but the wind will always flow. The speed may change, but this wind will flow. It will continue to flow, okay. That is something will never stop. So when I talk about types of wind, I am finding that erasing this red marker, the ink of red marker, is quite easy. That is why I am using this red marker, right? So when I talk about types of wind, the first one is the permanent wind. And when I say permanent wind, it means that there is some amount of permanency in it. Means this air flows throughout the year. It will flow throughout the year. It is never going to stop. For example, we have, for suppose, trade winds. We have easterlies, and we have also westerlies. These are the winds that will continue to flow irrespective of the season, okay. and we will look into all the three winds in a single diagram. So just do not worry about diagram, just write it down. Okay, so when we talk about seasonal wind, the other one is seasonal wind, and the name itself suggests what will it mean. So it will, this is not air, this is wind. This wind flows throughout the year. When seasonal wind, we call it flows during a particular season, and when I say particular season, underline it, just underline it, particular season. When I say particular season, it means its arrival or its flow will depend upon the season itself. For example, we have the world famous monsoon wind, the world famous monsoon wind, and accordingly we have monsoon season, right? Then the third type of wind is the local winds. Local, what do you mean by local? Local means something which is over a particular place only. Okay, when we say local, it means over a particular place only. So it will flow only over a particular place, and not just particular place, but also not just over a particular place, but also and over short period in a particular season. Let's say example is Lu. Lu is a air that flows in northern part of India. From UP, Bihar, you will also come across this Lu flowing in Delhi, northern India entirely. And this Lu will flow only in summer season, when the temperature at the surface is very high. So in that scenario you will find Lu. Then we have also nor'westers, Kal Baisakhi in West Bengal, and then we have blossom wind, land breeze, sea breeze, everything is there. These are all local winds. Means the nature of flow is quite localized. They will not flow over a very extended period of time or a very extended period of area. Now we will try to understand seasonal wind. You do not have to understand in much detail. It's the name that itself give you much more explanation. And then we have local winds, for example Lu, nor'westers, Kal Baisakhi, the same name. Okay, now try to understand this permanent wind in some detail, and for that we have a topic called pressure belt and wind system. And in this pressure belt and wind system, we will try to understand the nature of permanent winds that we have. Okay, we have talked about the trade winds and the easterlies and the westerlies. Now it's time to understand it in a diagram. So a very type of request I have, just be attentive at this point of time and don't just draw a diagram. Try to understand it first, and then you should also draw a diagram. So suppose this is the earth, right? So suppose this is the earth and this is the equator. This is the equator. So the equator passes through, the equator passes through 0 degree. So this is 0 degree, and above it, suppose this is 30 degree, and then we have a 60 degree line. Or then similarly in the southern hemisphere also we have 30 degree south and 60 degree south, and here is the pole which is 90 degree, and of course in the south pole also we have which is also 90 degree. So this is south pole and this is the north pole. Now, when we try to understand permanent winds and their pattern of flow, you know that the insolation that we have is maximum at this area, equatorial. This is called equatorial area. So we have maximum amount of insolation here. So suppose this is the land, the land somewhere in equator, at the equator. So here we have the maximum amount of insolation taking place. So whatever air you will have here, it will get warmed because of the temperature that we have of the surface. So this surface is very hot because of the insolation, because of the overhead sun. So the air that is lying above the surface will get heated up, and this heated up air will rise. So this air will now rise above, and so here you will have a vacancy, means the air particles that were here now have risen over here. So what will happen, that here the concentration of air particles will be very low, and that happens over the entire this area. That is why we call it equatorial low pressure, equatorial low pressure area. Okay, equatorial low pressure area, this entire area across the equator, right? And at 30 degree, what happens, the amount of insolation is not that much that you observe at equator. So when the amount of insolation will be low, when you have low amount of insolation, not that much amount of heating will take place at the surface. And since that not too much of heating taking place here, so the air will not rise very much. So what will you find, that here the concentration of air is basically very high. The concentration of air at the surface is comparatively higher than at equator. So this area is called high pressure area or subtropical high pressure area, or we call it horse latitudes. And similarly, this is also the same scenario here, subtropical high pressure area. So what will happen, as we have already understand that, suppose this is the subtropical high pressure area and we have equator here where the concentration of wind is very low. What will happen, this wind will start to flow here. Similarly, in the southern hemisphere also we have subtropical high pressure area, so wind will flow here. So what will happen, this wind which is concentrated at this subtropical high pressure area will now start moving towards equator. And similarly, from this area also you will find that wind is flowing towards equator. This wind that is concentrating, that is getting concentrated at equator from both these areas, these winds are called equatorial. They are concentrating at equatorial low pressure area. They are called basically trade winds. They are called trade winds. In this air is called northeast trade wind. This is called southeast trade wind because they are coming from east direction. That is why. Now this is subtropical high pressure area. Again, this area is polar area, and in this area we have low pressure area created, not because of type of the mechanism that we have seen here. This is another phenomena taking here place. This is, just remember that is, this is polar low pressure. This is polar low pressure, and similarly this is also polar low pressure area. And since this is low pressure area, what will happen, that you have good amount of concentration of air here, and here we have again low concentration of air, and again here we have low concentration of air. So this wind will also flow here. Okay, so what will happen? This wind will flow in this way to polar low pressure area also. Okay, so this wind will flow like this. Now this wind, since coming from western direction, you will see on the map, you all already know that whatever in the right hand is called east, and whatever in the left side is called west, and in upper side we call north, and in lower bottom side we call south. So that is why these winds are called westerlies. These winds are called westerlies. Okay, and you know that at the pole we have minimum amount of insolation that is taking place, and because of this minimum amount of insolation taking place, the air that is at the surface is not that much, getting heated up, and because there is no or little or no heating of air, we will find that air is just concentrated on this surface. Air is here concentrated at a very high amount of concentration is there, very high amount of concentration. So this will also flow towards low pressure area. So what will happen in this wind will flow toward this area. Okay, from poles to polar low pressure area. And since this wind is coming from east direction, you will see the direction of wind, it is coming from east direction. That is why we call it easterlies. That is why we call it easterlies. Similarly, this is also easterlies. Okay, so this was the whole mechanism of these permanent winds that you come across on the earth. These are three permanent winds: trade winds, westerlies, and easterlies. These are three permanent winds that will flow throughout the year, 365 days, 24 hours. Okay, 7 days in a week. So this is a wind that will flow 24 into 7 into 365. It is never going to stop. Of course, there will be change in the wind speed, but the wind will flow. Okay, it will never stop. So this was the whole idea of this topic called the pressure belt and the wind system. Okay, hope you have understood it in a very crystal clear manner. So now next, just draw this diagram 2 to 3 times in your copy or in your notebook, so that you have great clarity of mind. Okay, and write this 60 degree, 30 degree. These are very important. Okay, these are very important, because if you do not mention this, you will not find from where this wind is coming from actually. So that is why mentioning those 30 degree latitudes are very important. Okay, so this was the idea behind the pressure belts we have and the type of wind, the permanent wind that flows. The entire mechanism is now understood. Okay, so now next we will move to a very simple concept that is called cyclone. Okay, so next we have cyclone. When we say cyclone, it is an intense wind circulation over a low pressure area. It's an intense wind circulation intense wind circulation means wind is circulating at a very fast rate, okay, and over a low pressure. This whole system will start over a low pressure area. Always remember this. Sometimes you will find that this low pressure area is named as depression in case of cyclone. So this is called depression when we talk about cyclone. So basically this depression is an intensely low pressure area where wind will flow from west to east direction. In this direction you will find that wind is flowing, and here is low pressure area created, and it will continue to flow in this manner, right? It will continue to flow in this manner, okay, right, in west to east direction. So this was the idea of cyclone. Usually, not usually, cyclone will form only at the sea, okay. So what happens that this is sea and this is suppose land. So a low pressure area will be created at the sea, and what will happen, the wind will start flowing from west to east direction. So in this fashion you will find that wind is flowing, okay. In this fashion wind will flow, and this low pressure area because of low pressure area, you know, low pressure area is created where the temperature is very high at the surface. So the temperature here at the sea level is very high, sea surface temperature is very high, so the winds are ascending like this. So as it will circulate in a very intensive manner, the water that is here, it will also move, okay. So a great amount of evaporation takes place here because of intense heating, and this moisture is, you know, this moisture, we will deal with moisture and humidity, we will you know, in a separate topic. So let's try to understand the humidity itself, because cyclone, you will see, if you can't understand it without humidity. So let's understand what is actually humidity is. So when we talk about humidity, it is the amount of moisture, and when I say moisture I mean water vapor. I say water vapor present in air. What is the amount of moisture, what is the amount of water vapor that is present in air? That will be called its humidity. For example, suppose if this is the air particles, we have air particles, this is air particles, okay, and within this air particle you will have some water vapor as well. You will have some water vapor in this air, okay. These are water vapors, and of course you will have some amount of dust particles as well. So this black represents dust particles, not a very high concentration. If you are in Delhi and it's winter season, this black colored will be very high, that is PM 2.5 and PM 10. Of course that is another issue altogether. Here just concentrate on these red points, these are the water vapors. At the sea you will find these red points are very maximum, and at the land this will be very low. So this is the concept of the humidity. The amount of water vapor that is contained in air is called its humidity. Now try to understand cyclone. As we have dealt with this, when what happens when you have sea water and it gets heated up, the air that is present here, of course it will get warmed, and so it will rise up. So these air particles will now rise up, and here a low pressure area has been created. So this air which has risen up, here will be a low pressure area created, and the wind that is around this area will rush to fill up this area. So what will happen, that a circulation will be created here in this way, where wind will flow from west to east. Wind will flow from west to east. Okay. And because of this low pressure area and wind is rising because of temperature rise, the water that was contained at the surface will evaporate very quickly. And this wind will have a great amount of, so suppose before creation of this low pressure area, this cyclonic condition, we have this amount of water vapor in the air. Now after this situation has been created, the amount of vapor will increase up to a great amount. It will be increase up to a great amount. Of course there will be very less amount of dust particles in sea. And now at land, the water vapor, because of evaporation, you will study in higher standard, because of evaporation a great amount of energy is also generated here, and so the intensification of wind is further aggravated. So this wind will now start move, this wind now start moving in this towards land, and as it will reaches land, what will happen here, the water is not there. So the evaporation that was taking place and the energy that it was getting, that has stopped. So what will happen when this will get here, you will find that this intensity of air, the wind, the speed with which wind was flowing, it has reduced, and because of reduction in the speed of wind, you will find that the cyclone after some time has come to an end with a heavy amount of rainfall. So with this idea of rainfall, let's try to discuss the rainfall as a concept, because we have the next topic, the rainfall, in which we will again see how this rainfall because of cyclones occur. So let's understand the rainfall. So when we talk about rainfall, how rainfall occurs, the basic mechanism is that there is water, and with increase in temperature the water converts into water vapor. This is water, this is suppose water, and because of sun's radiation it has got heated up and it has been converted into water vapor, and now this water vapor will rise up along with air. And it rises up, the temperature goes down, and as the temperature goes down, this water vapor which was in gaseous state, it will now convert into solid state. This will condense into water droplets. So it will become water droplets and it will form cloud. So this condensation of water vapor into water droplets is called cloud. And when the concentration of this water droplets increases in the cloud, the air will not bear that much amount of water droplets in it. Always air has some amount of water droplets, that is called what we have water vapor in air, and when it goes up, this water vapor which was in gaseous form, it converts into liquid form. The tiny water droplets are there, but air has some amount of capability to hold this even water droplet. But after a certain amount of time, when this water droplets get concentrated in too much amount, the air is not able to hold this amount of water droplets, and that is why this water droplet will come to the earth as rainfall. So when the concentration of water droplets increases here, the air is no longer able to hold this water droplet, and so you will find that it will come on earth as rain. So this is basic mechanism of rainfall. So this was basic mechanism of rainfall, right? So when we talk about types of rainfall, we talk about three mechanisms of rainfall. So first is the orographic rainfall. Orographic, or you say relief rainfall. Then we have cyclonic rainfall, and then we have another rainfall called convectional rainfall. So the third is basically convectional rainfall. Okay, the basic mechanism behind all this rainfall is this, but try to understand this orographic. Orographic means something which is has been caused due to mountain or some physical features. So when we try to understand this orographic rainfall, you have to understand that whenever you have a mountain, suppose this is mountain, and air here has some amount of air is here, concentrated air, and as the temperature rises, this air will also move up, so it has some water vapor in it. Now because of rise in temperature at the surface, this air will now move towards the mountain. So the air is now moving. As it encounters this slopey surface of the mountain, it will now move upward in a very rapid speed. And as it is moving upward, the moisture that is here, the moisture is also moving upward, and after some time this moisture that we have, this water vapor that we have in the air, it will get condensed into water droplets and it will form cloud air. Again some amount of air will go, and again this water amount of concentration of water droplet will increase. Again some air will go and water droplet will be concentrated here. A time will be reached when air has no further capability to hold this much amount of water droplet. As a result, what will happen? It will fall to the ground as a rain, and in this side you will find that the rain has occurred. Okay, so this is the basic idea behind orographic rainfall. Now you have cyclonic rainfall. The basic idea behind cyclonic rainfall is that at sea, when the temperature of the sea surface increases, here you will find that there is a creation of low pressure area, and because of low pressure area, the wind around this area will rush into this part and it will start circulating in this fashion in west to east direction. And because of the rate of evaporation that is occurring here, which is very high, it gets some amount of energy from rate of evaporation, and as it moves towards the land which has colder air, suppose here is colder air, and of course this is warm air, right? This is cold air, not a mountain. This is cold air here at the land. So as it moves here, what will happen? This cold air is acquiring this land surface. So as it will encounter the cold air, the warm air will rapidly move upward. The warm air, what will happen? It will move rapidly upward, and the same phenomena will repeat. The moisture that is contained in this warm air this moisture will get converted into the water vapor, will get converted into the tiny water droplets, and there will be a formation of cloud. And as when more and more air moves and goes upward, because of going upward, because of increase in altitude, the temperature will fall, and more amount of water vapor will be converted into water droplets, that is cloud. And a time will reach when air will have no further capability to hold this moisture, and that is why you will find that rain has occurred here. This is basic mechanism of cyclonic rainfall. So this is rainfall which is caused due to cyclone. Then we have convectional rainfall. What is this convectional rainfall? The basic mechanism that I have dealt with, that is convectional rainfall. So suppose here is a water body, and the temperature, the solar radiation has heated this water, and what will happen? The air that was there, the air particles that is here, it will get heated up, and also some amount of water will be converted into water vapor, and that will be in the air particles itself. And as the air will rise, these water vapors will also rise, and as it will go up, this water vapor will convert into a smaller water droplet, teeny water droplet, and it will form cloud. and when more and more water droplets will reach this height, more and more water droplets will be forming clouds, and a time will be reached again when air will have no further capability to hold this amount of water droplet, and what happen, condensation will take place and you will find that rain has occurred in this area. So this is the basic mechanism behind convectional rainfall. So this was the type of rainfall that we have to study. So I think you have understood all the phenomena in a very crystal clear manner. Okay, if you have any doubt, first go through this entire lecture once again, make your notes, make diagrams, and I am 100% sure you will find no further any type of difficulty in understanding all these concepts. Okay, so if you have any friend, just share this lecture to him so that his understanding of geography is also enhanced, he also gets clarity on these concepts. Okay, so this was the, of course, having clarity in mind with regard to geography is the basic motive behind this lecture. So share it and do hard work as much as you can do. So this was the end of this chapter. We will meet in the next lecture with a new chapter. Okay, up till that, keep working. Goodbye.